Radio TV Phono Nut here, and we have a picture of a radio which was a gift from a friend, and you'll see the radio in person here shortly. This is a small Tempest brand 5-tube radio that was made in Japan. These types of little radios from Japan were sold under numerous brand names and offered in numerous cabinet styles, and they also came in many different colors. This one here I think is the most common, and they were offered from probably the late 1950s until well into the 70s, but I think most of the versions offered during the 70s were in kit form. It got to the point where you could buy these in discount stores for under $10. I know a TV repairman that I knew a long time ago. He told me sometime around 68, 69, one of the local discount stores had a ton of these radios left over that they were just itching to get rid of to make room for the newer solid state models. And he said I ended up making a deal with him to buy every one of them that he said amounted to about, he said probably about $1, $1.50 a radio, and he said I didn't plug the first one of them in. He said the only reason I bought them was to get the 5 tubes out of them, which were the same tube type numbers as what was used in the American-made sets. He said I couldn't go to the parts house and buy the 5-tube complement for as cheap as what I paid for those radios. So he said, you know, I knew they were cheap junk, so I ripped the tubes out of them and tossed the rest in the garbage. Now, of course, back in 68, 69, these were considered cheap, disposable, throwaway junk, but now they're rather collectible, and some of them go for pretty good money, especially the ones in the colored plastic cabinets. I don't know who actually built these, but this one has Futaba branded tubes in it, and the speaker has that same emblem on it, so I'm guessing they're probably the ones who made the radio. I'm also told that Fujitsu made some of these. I couldn't tell you. I know there were some, I think, that were made, some better quality ones that were made by Panasonic and Toshiba. Some of those were on a printed circuit board chassis, but they all used basically the same circuit. Now, this radio plays, but before we put it into full-time service, we're going to have to do some things to it. Notice the tuning condenser is a little staticky towards the bottom end of the dial, so we probably have dirt between the plates or touching plates, and the volume control needs a squirt of cleaner. There's the back of the radio. In most of these sets, this one included, has a metal heat shield that attaches to the cardboard back of the set that helps prevent the heat from the tubes from damaging the plastic cabinet. These things run awfully hot, and even though these have a heat shield, I've still ran into a good many of these that were high-hour sets that had warped cabinets, stress cracks, and some even had holes burned through the cabinet where the plastic melted. Now, at one time there was a schematic diagram pasted to the bottom of the back cover there, but we can see that's long gone, but I really don't think that's going to be needed anyway. There's the underside of the chassis. Now, some of these sets used all disc capacitors. Some of them used a majority paper and oil type capacitor, and this set here falls into the latter category. Now, those gray paper and oil Japanese capacitors, they tend to be very leaky, and this one right here, you can see one terminal of it connects to the one side of the power cord, and then the other terminal of it comes up here and connects to the other side of the power switch. So essentially this capacitor is wired across the AC power line for RF noise suppression. These capacitors are notorious for exploding and sending shrapnel everywhere. I've had it happen more than once in these little Japanese radios, so before we even do anything, we're going to go ahead and replace that capacitor with something else, something a little more modern and safer. Over here we have our electrolytic filter capacitor. Those seem to hold up surprisingly well in these little Japanese radios, and this one seems okay, so it's probably gonna stay put. This gray capacitor here looks to be our coupling capacitor that couples the plate of the first audio tube to the control grid of the output tube. That probably needs to be replaced. What is this capacitor up here? That looks like a possible plate bypass cap for the output tube, so that might need to go. This capacitor here coming off the center of the volume control, that just couples the volume control to the control grid of the first audio tube, and there's really no voltage to amount to anything there. This 0.05 here that connects to one side of the volume control, which should actually be B-, and over to this point, that's the AVC filter. No real voltage on that one either, so unless it gives me a reason to change it, I probably won't mess with that. And then let's see what else. We have this one here that I believe connects between B- and chassis. Its purpose is to provide an RF ground for the chassis there, so might want to change that. It looks like it's leaking some little wax out of it there. So these things are pretty simple. Now these sets, performance-wise, like I said, they were a cheap discount store, under $10 radio. I find a surprising number of them that still work on original components, but they tend to sound kind of tinny, and they don't appear to be as hot of a performer as some of the bigger sets do. And I think the reason for the tinny sound is probably because of the little small speaker, and these things technically only have one IF transformer, and then they have a coil between the converter and the first IF amplifier tube, so I think the IF stage may be another reason. But one thing about these Japanese IF transformers, they usually have real capacitors in them, so no silver mica disease to worry about. Alright, standard 5-tube line up here, 12BE6, 12BA6, 12AV6, 50C5, 35W4, and a little small ferrite antenna, and I've seen some that were smaller than this, and that probably helps contribute to the lower than average sensitivity of these radios, but to be as cheap as they were, you really can't complain about them. Alright, so let's tear into it and do a few things to this and get it working properly. Alright, we got the old capacitor out, but I'm going to have to make a slight modification. This little phenolic piece here, that's I guess a cheap version of a terminal lug, where they had the capacitor connected to one side of the switch there. There's no kind of insulator under this, and the way this was in here, it could very easily short out to this chassis. So we're gonna cut a small piece of material to put under here between this terminal lug and the chassis to prevent any shorts from taking place. Alright, let's look at the picture again, and I'm going to clarify what I'm talking about. First off, the chassis in this receiver is not connected directly to one side of the AC line. If it was, this up here with this little terminal tie point thing wouldn't be an issue. Instead, we have this cap here connected between B-, which is this point right here, and the chassis. So what goes on here, we have our power cord coming in, going to the rectifier tube there, connected to the plate and the beginning of the filament string, and then we have this capacitor, one end of that capacitor connected to this point, and then we have the other end of the capacitor connected to this point here. So if we look at the other end of the power cord, it's hard to see, but there's a yellow wire under here that they're using an unused terminal lug on the tube socket for this tie point. So the power cord connects here, and then we have a yellow wire that runs up through here and connects to one side of the off-on switch. And then the other side of the off-on switch, one of the blue wires here, goes back around through here and connects to our terminal tie point here. And the way this is in there, the other side of that could very easily touch that chassis. So we're going to fashion an insulator out of some thin cardboard or heavy-duty paper or something. Maybe the junk mail we get will be useful for something after all. And we're going to make a little insulator to make doubly sure that this point here from the other side cannot touch this metal chassis here. And this .05 cap is unbranded, by the way. They were ashamed to put a manufacturer's brand on it. I don't have any .05 across the line capacitors. I have some .1s, so that's what we're going to go with in this application. It's really not that critical. This is just for noise suppression, and a .1 should do just fine in that application. Alright, we got the cap changed, and I actually goofed a little bit. So this bolt actually does double duty. It holds the output transformer, or holds one side of the output transformer in place, and there was actually another nut under here. So the way this originally was, it was bolt, nut to hold the output transformer, then this terminal strip, and then another nut on top of that. Well, everything had worked loose, and this was kind of flopping around a little bit. But it's all tight now, but I did still put the insulator under that just in case. And then we have the leads of the capacitor sleeved, so they won't touch anything. There was a small enough hole in this tube socket terminal that I was able to put my capacitor lead through it and do a good mechanical connection. But as far as the power cord, I just had to tack solder it on just like they had it done from the factory. So at least we won't have to worry about this cap exploding again, or exploding in the future. And a little later we'll check this one and see just how leaky it may be. Alright, let it warm up here and see how it does. And seeing as how it's after midnight, maybe we'll pick up some out-of-town stations. We are, but that tuning condenser is dirty. I need to clean that. I've already cleaned the volume pot.
Who are doing it for a paycheck, there's probably a lot more of them. Just that curiosity.
That must be $13.90.
Around to make emergency landing backing out.
But yeah, it's getting some distant stations. We're on the top end of the dial. I just hope I can clear this tuning condenser up. I had one time that I ended up scrapping because the tuning condenser had issues, and no amount of cleaning in the world would get the static out of it.
His signature repayment plan to let them know.
I don't know what that is.
Yeah. And you and I looked at that because Oregon, Washington.
That's got to be WSM right there. And it seems after turning this thing a little while, the problem may be clearing up.
Florida. Out of there. Action completely. Right. But it was like watching a tennis match for us. We were just going back and forth looking left coast, right coast, left coast, right.
Alright, good. Good. I'm happy with our progress so far. Alright, we're getting a nice wide eye opening here. It's pretty close to the value it should be. Alright, let's check it from leakage. Yeah, see, we got a little bit of leakage there at 200 volts. And then, of course, the more voltage we apply, the more it's going to leak. This is certainly not the leakiest one I've ever seen, but it's not. If we'd have kept using it, that would have eventually shorted and blew up. That's with 400 volts applied. And at 600, it's really showing out. Okay, alright. Alright, checking the control grid voltage of the output tube with respect to cathode of said tube. I got negative 6.8 volts, so that's not too terribly bad. But really the best way to check a coupling cap for audio is to lift the grid end of the cap, connect a DC voltmeter to the lifted grid end, turn the radio on, and if we see any DC voltage at all, then that cap is leaky, because a cap is supposed to block DC. So let's turn it on and let it warm up a minute and see what happens. See if we get any DC pass through here. A little bit. Not too terribly bad, though. Which is really shocking, really. See, it's pretty much settling at 0 volts. So, this cap may be in pretty good shape, actually. I'm checking this on the cap tester. I'm really not getting any eye opening here. I'm getting a little bit of flicker right in here that you probably can't even detect on camera. So I think that capacitor is lossy. Now I'm going to check it for leakage, but before I do, let me say on the DC side of that cap, the plate side, normally there's not going to be much there. On the detector tube / first audio tube plate, maybe, what, about 40-50 volts at most. So what I'm getting at is this thing may actually show leakage at 400 to 600 volts, but possibly no leakage at 50 volts. So let's see. Let's just see. We're having fun with this. Let's see. So yeah, 50 volts. We've got basically nothing. What about at 200 volts? Looks to be okay at 200 volts. 300 volts. And finally, the highest setting. And it looks like we're leak-free, as our voltage test a little earlier indicated. But our value is just not showing up too well. We're not getting any value on here. It's acting like this thing is open, really. So I might just go ahead and replace that with a good cap, and that might improve our fidelity some. Alright, on the .001 to .05 range, I was getting nothing. On the one that goes from bottom end up to .005, I'm getting a little puny little eye opening here at about, what is this, about .006, somewhere around in there. Alright, here's a new .005, and I'm getting a much better, more well-defined eye opening on that cap. Let's see if we get anything on the next highest scale. We should. Yep. So I think we're just going to replace that and see if that improves our fidelity any. Alright, there's the new cap, letting the set warm up. See what happens.
In times of need, lions always find a way. And after we...
Sounds like WMOX with an unmodulated carrier. Not unusual for them this time of night.
You got parity in a lot of things.
Well, it looks like the noisy tuning condenser corrected itself. So I think I'm about ready to put this back together. These other capacitors, there's really no danger with them. I mean, there's this one down here that connects between the chassis and the B-, but I'm not even going to worry about that right now. These other two, the AVC filter and the coupling cap for the volume control, it's no big deal with them. So, and the filter capacitor, it's been my experience, the electrolytics in these sets, if they work, whenever you find the radio, it's probably going to keep working. So we're just going to leave it at that. These electrolytic capacitors in these sets seem to be pretty reliable. Alright, we're back together. I'm going to have to replace these little rubber bumpers under here that for the chassis mounting screws. They're all rotten, but that won't be a bit of problem. I just need to dig some up. WSM coming in pretty good.
That was great, though. Okay, never call there.
What's this? Somebody playing 1960s era Bee Gees? I wonder if that's 740 out of Toronto. It's about the right spot on the dial for it. Fifth dimension, one less bell to answer. If we had something like this locally, that would get me more motivated to fix these old AM radios more often. And I can visualize some kid back in the late 60s, early 70s listening to this on a radio just like this. KTRH, I believe, is what I heard. Okay, that was indeed KTRH 740 out of Houston, Texas, and according to this and their website, which I'll admit I didn't peruse very deeply. It's getting late and I'm ready to go to bed, but everything I'm finding says that they're a news talk station, but as you could tell, they were definitely playing oldies just a few moments ago, so we can only assume there's a few things we can take from that. Either the oldies is a nighttime thing, or maybe this is some kind of special occasion when they're playing oldies, or perhaps there was a recent format flip to oldies and they just haven't updated their information yet. But as it so happens, there's a station in Canada at 740 that everybody raves about. But unfortunately, I really can't get it down here. I think I picked them up once or twice, but the signal was so weak, I really couldn't get any kind of enjoyment out of it. But they are a 50,000 watt station, and they've been around in some form or another since 1922. And it looks like they had frequency changes about every time the wind changed direction, at least in the earlier days anyhow. Owned by iHeartMedia. And it looks like they have a repeater on 99.1 KODA HD2. Let's see what that is. Alright, KODA HD2, Sunny 99.1 is an American commercial adult contemporary formatted radio station. Well, I guess that what we heard could be considered adult contemporary. So maybe they were having some trouble with their talk feed on the AM side, so to have some programming there, they just fed this to the AM station. I don't know. But I will continue to try to pick them up and see if the oldies format continues there. Okay, we have the radio back together. And just to recap, we basically did some preventative maintenance on this. We replaced the across-the-line capacitor, which was leaky, and would have eventually gone kaboom. The plate to grid coupling cap of the audio output tube was not leaky, but it tested lossy, so I just went ahead and replaced that. Then we had a staticky tuning condenser, but this set uses one of those innovative self-cleaning tuning condensers from Japan, so all we had to do was run it back and forth a few times, and the problem magically went away, and we put it back together, and that was that. I think this volume control has an intermittent condition, because I noticed a couple of times that even with it all the way down, it doesn't go all the way down, and I've seen that problem on these controls, but usually when that happens, it's not intermittent, it's a permanent condition, and the only thing you can do is replace the control.
The other thing is, I was talking to Christian, and
right now it seems to be behaving.
the funny thing is about that hint that I...
Praise 95.9 FM and Praise 910 AM. Make some noise if you love the Lord.
That's not the kind of gospel music I can hang with,
Go out
by the way.
Buy a spray can.
That's 1390, the Southern Gospel Station.
Epic collapse. The Eagles team after starting 10-1. Let's keep our attention on the NFL.
That's the Fox Sports Station, which...
Consider moving on from their young star wide receiver channel.
Sitting here and listening to the grass grow would be more entertaining than listening to that.
Incredible Super Bowl performance.
That's 670, coming in very faintly, which for this type of radio, that's pretty impressive that it's even coming in at all.
The only connection to you are your text messages or the little blinking lights when you're on hold. And
so this one's ready to go. Yeah, as far as WMOX, they've been around since 1946. They started out on 1240 as a 250-watt station, and I believe they remained at that frequency until the early 60s when they went to 10,000 watts at 1010 kilocycles, and they were a top 40 station until the late 70s, at which time they flipped to country. And then in 1989, they added Rush Limbaugh, and from about 89 until the mid-90s, the number of talk programs just gradually kept increasing until one day the music died altogether. And when that happened, there were commercials on TV. We can listen to Meridian, and now we're 100% talk. I remember saying to myself, you didn't listen to me because nobody asked me what I wanted. I was talking to one of my friends, it was a DJ there at one time, and he said, well, by that time, our ratings were in the toilet, everybody was listening to the FM country station, and it was either changed to a format that would sell or go off the air, and he said, and talk radio was doing really well for us. Well, I think it really did well for them until 910, which was the urban hip-hop station that briefly changed to black gospel, adopted a news talk format, and that gave MOX some competition. And then way later, 910 started simulcasting on 102.1, and then another talk station on FM, 103.3, appeared. And then within the past few years, 910 broke away from 102.1 and started carrying a black gospel format. So basically all of the popular talk shows are on the two FM stations now, and I think WMOX, they're just carrying whatever they can get for the least amount of money to keep a signal on the air. Like I mentioned before, in the afternoons after Gallagher goes off, they run a Christian program that's also carried on 1390, and then after that they run Fox Sports, which is also on 1450, and I mean, you would think these stations would be a little bit more creative and run something besides programming that's on a competitor station. I know somebody who's sort of affiliated with them, and I just ran it past them. Why don't y'all just go back to playing oldies, get back to the kind of music y'all played back in the 60s and 70s? And they said, well, that's fine and good, but if we did that, we'd have to pay royalties on the music. And I'm thinking, yeah, but if you ran a unique format that nobody else is running, you might actually gain some listeners, which would equal more advertisers, which would equate to more money. But I think some people haven't caught on to the concept that there are times that you have to spend money in order to make money. So I guess we'll just be stuck with third or fourth rate programming on WMOX just to have a signal over the air. Oh, and that station we were receiving last night out of Texas, I think that must have been a fluke, because I tuned in to them a little bit later and they were back to talk programming. So, but at least we did get to hear a few moments of oldies being played on a 50,000 watt station. Okay, as we end this, I thought I'd show you my little collection of these little 5-tube Japanese sets from the 60s, late 50s, and into the 60s. I think this is all of them. So we have this one here, this Lundala little set here. It's in a blue plastic case. I think this is probably the oldest one. And then we have this J.C. Penney model. I'm not sure who built this one, but it's a 5-tube set on a printed circuit board chassis. It needs a power cord, and I think the speaker has a rubbing voice coil. Here's the schematic diagram. We'll try to get that in tune here so you can look at it if need be. And this is about the same diagram as all of these radios. I don't know how well that's showing up on the camera, but you can pause it if you need to. And then we have this blue Monarch Hi-Fi Master. That's back when they were putting the Hi-Fi badge on everything. That was a real selling point back then. This one's a little bit lighter blue than the other one that we looked at just a few moments ago. And then we have this pink Monarch Hi-Fi Master, and this is the only one of these that I've ever seen with a tone control on it. I think there was also a version of this that was an intercom version that had a separate unit that plugged into the radio that could be used in another room as an intercom. And then we have this Claricon, which is basically just a white version of the two blue sets that you just saw. And then we have this gray Zephyr that's basically the same design as the little blue radios. And we have this set here, which is an Iowa. I think this is probably a later model one. I believe Lafayette also sold a kit version of this radio into the 1970s. And it too is built on a printed circuit board chassis. Here's a Stratosonic radio, which is basically the same thing as the Tempest that we just worked on, except this one has a different name badge on it. And like I said, these things were sold under many names. I've seen these sold under, well, obviously Stratosonic, Tempest, TDA, Invictus, Juliet, and then there's probably more of them if I put my thinking cap on hard. And this one still has the schematic pasted on the back. We'll try to focus in on that in case you need that for anything, but I think it's pretty much going to be the same as the Pennies radio. And here's another one, a Hi-Phonic. Yeah, that's another name to add to the list. 5-tube super heterodyne bed radio. General International Corporation, New York, Tokyo, and Seattle, made in Japan. And this is just a black version. As you can see, this is just a black version of the Tempest, except this one uses metal screws to hold the speaker grill in place. The later ones use plastic screws, and the tuning knob is a little bit different on this. And the back cover is a little bit different. They only have the heat shield over the rectifier and output tubes, whereas the later one has the heat shield across the whole back of the radio. And this one has the schematic on the bottom of the set. Just leave that there a minute for you to pause and peruse if you choose to do so. Brings us back to the Tempest that we just serviced. Now, all of these radios I have done something to. I think, like I said, the pennies, I think it has a rubbing voice coil, and one of the blue ones had some intermittent problem that I never could track down. Maybe I didn't try hard enough, but I believe all of these play to some degree. Yeah, I pick these up when I can find them for a reasonable price, but I'm certainly not going to get on eBay and pay the ludicrous amounts of money that they want for some of those on there. In fact, it's getting so about everything on eBay is overpriced. I think with all of their stupid new policies and other crap that's taken place in recent years that I won't get in a rant about, but I think they've pretty much ran off a lot of the small-time sellers who would be willing to sell something like this for a reasonable price. Pretty much all you got now are these ones that will put something on eBay for a ridiculous price and let it sit there for 10 years in hopes that a sucker will one day come along. Now, I don't know why the Japanese did it this way, but this seems to be universal among these types of radios. In an American-made set, you would have had an IF transformer, meaning a primary and secondary, between the converter and first IF tube, and then you would have another IF transformer between the IF tube and the detector and first audio tube, which they have here. But as far as between the converter and the IF amplifier tube, as you can see, they have a capacitor coupling the plate of the converter tube to the control grid of the IF amplifier tube, and then we have this coil in parallel with a capacitor connected to the plate of the converter tube, and then the other end of that coil we have our B+ voltage going in there. That's sort of acting like a trap, I believe. And then of course coming off of the second IF, this only has one IF, but coming off of the IF amplifier tube, we have a conventional IF transformer like you would see in an American radio. Now, oddly enough, on this radio, they have a conventional IF between the converter and the IF amplifier tube, but on the output of the IF amplifier tube, they have the capacitor coupled deal in the trap like they were using for the first IF in the other radio. And here's one of the other radio schematics. Okay, so there's what I've got so far, and I've taken pictures of the schematics, and if I can get them to come out clear, I'm going to try to post some of those at the end of the video, so for reference material in case anybody needs them, because like with the Tempest radio, the schematic was long gone off of that, and these generally were not covered in SAMs. So I've seen a few of them that were, but a lot of these were not. So I realize it might be helpful if somebody's working on one of these to have the schematic, so I'll try to provide that.